Tracker is a motion capture software in a computerized video analysis system on the Java environment in which, by means of certain defined reference points of a real movie medium, it's able to calculate their travel paths. It uses a type of recording that by means of photogrammetry allows to calculate and understand the movement of a real object, commonly to later transfer it to a digital medium or further analysis. This type of video analysis by Tracker allows the option of performing the digital virtual modeling of the system for its final rendering, creating kinematic and dynamic models of one-point mass or two-point particles that are to be analyzed with respect to the real model. One of the main advantages of the Tracker software is that it is free software from open source physics, and therefore free of costs, with constant progress in effectiveness and speed due to contributions from third parties. The software has a very user-friendly interface with great rendering capacity, and due to the automatic nature of the analysis and rendering procedure, it is very easy to use. Downloading the software Tracker is very straightforward. The latest version is the 6.0.1. It can be installed on Windows and Mac OS through the page fizzlets.org/tracker. Tracker comes with its own integrated Java and Subul video engine. So to install it in the two mentioned operating systems, it only requires downloading and running the installer through the link provided on the same page. The minimum requirements are Windows Vista onwards with a 1.5 GHz processor or higher, 1 GB of RAM, and an integrated graphics card. It's recommended for higher speed. For now, there is no official version for Linux, so in this case, it is recommended to install a Windows interface through a program like Wine, then install Java for Windows in the same interface. Some Tracker packages for Linux can be found at the link provided here. Tracker comes with the option of being downloaded into an external drive, for example, USB. For this, install download straightforward, but when it asks you for the directory folder, you just have to define it in the external drive and then proceed normally.
Next, we have the applications. Well, at the time we are analyzing a dynamic phenomenon, we have to pay attention to certain elements as position, speed, acceleration, angular velocity, etc. Usually, we analyze all of them in a laboratory with special tools and precise technology. But what happens if that experiment can be replicated in a laboratory, or we don't have the equipment to perform these measurements? Well, in that case, we can use a video analyzer to help us to model the behavior of our experiment. For example, we can obtain the curve of change of position with respect of time of an object in movement, a car, a person, or any object in movement. We can know the behavior of a parabolic shot of a cannonball, an experiment that cannot be replicated in a laboratory, as you can see in the picture. We can also analyze oscillatory phenomena such as pendulums, air shock absorbers, or any element that make use of springs. You can see in the picture the famous slingshot, or the jump of a frog, and its position in time can be analyzed too. So we can see that Tracker is very useful in this case when we don't have too many tools to analyze our phenomenon other than a video camera and a computer. From them, we can observe interactive vector systems that give us position information, speed, acceleration, or other variables we need.
The tracking motion software got a lot of application on the engineer world. Most of them in the process of understanding the nature of a physical event used to develop technology for the common life. In the bionic engineer, we use tracking softwares to analyze biological phenomena to understand their movements and behaviors. The goal is to, based on the phenomenon, to create machines with the same characteristics. The tracking motion allow us this kind of analysis, watching their movements of the study object. For example, out of walking or a bird in fly, we can study many of them and then develop a kind of processes for a dog or a plane based on the bird's physiology. That's the tracking motion in the bionic engineer.
The practice exercise that we made is about the movement of a toy car on a racetrack with a loop. I'll start the video. We can see these marks. This mark is the position points where our car has been over the time. And this allows that the software make the corresponding graphs. In this part of the software, we can see two graphs. The first graph, it's about the displacement in X with respect to the time. And the other graph, it's about the displacement in Y with respect to the time. In both graphs, we can see an elevation. And this elevation, it counts for the loop in the track because in the displacement in Y, we can see an elevation in the loop, and this produces the elevation in the graph. And the graph for the displacement in X, it counts for the return in the loop. Well, below to the graphs, we can see dark tables. And this is the marks, the old marks about the car, and his values in the time, the displacement in X, and the displacement in Y. We can add more values that we need, like speed or acceleration.